In this video, we're going to be looking at hypothesis testing. And specifically in this section, we're going to be looking at the language of hypothesis testing. So what exactly is a hypothesis? Well, in non-statistical terms, a hypothesis is some sort of a statement that we believe to be true. Our experience or our evidence suggests that this thing is supposed to be true, whatever it is. And so we hypothesize that we believe whatever it is true. Well, in statistics, a hypothesis is the same kind of thing, except we're going to be talking specifically about populations. So a hypothesis is a statement regarding a characteristic of one or more populations. So it is something that is supposed to be true about the population. Now, why is it supposed to be true? Well, it may be that historically it's been true. It may be that someone is claiming that it's true about the population. Or it may be that there's a manufacturing specification that states that it's supposed to be true. So, for example, suppose that a television commercial claims that 3 out of 4 dentists recommend a particular kind of toothbrush. Well, then the hypothesis would be that the proportion P of dentists that's recommending this particular toothbrush is 3 out of 4. So the hypothesis would be that P equals 3 out of 4. Or we might write that in decimal form. P equals 0.75. So why is this supposed to be true? Because the commercial's saying that it's true. So that's the hypothesis. Or maybe we're thinking more in terms of a can of soda. So a can of soda is supposed to have 12 ounces of the beverage in it. So on average, there's supposed to be 12 ounces of soda in the can. So our hypothesis would be that mu equals 12 ounces. Now what we're going to be doing is we're going to be testing these hypotheses. We're going to be testing to see whether our evidence supports that this is true or refutes that this is true. Our evidence is going to either support that this is true or it's going to refute this is true. And so that's what we call hypothesis testing. So definition: hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. So that last part of that definition was what a hypothesis is. So we're going to be testing a hypothesis using sample evidence and probability. So again, we're going to gather a sample and we're going to see if our sample supports that 3 out of 4 dentists actually recommend this particular toothbrush or not. We're going to gather sample evidence and see, does our sample evidence support that there's 12 ounces of beverage in the soda can or not? So that's what we're going to be doing with hypothesis testing. So in this particular section, again, we're primarily going to be focusing on terminology, and then in the next 2 sections, we'll actually be conducting hypothesis tests. So the steps in a hypothesis test: 1, we're going to make a statement regarding the nature of the population. So again, particularly in this chapter, that's going to be a statement that a parameter equals a particular value. So again, like P equals 3 out of 4, or mu equals 12 ounces. Step 2, we're going to collect evidence, in other words, sample data, to test the statement in step 1. Step 3, we're going to analyze the data that we collected in step 2 to assess the plausibility of the statement in step 1. So again, we have something that's supposed to be true. We're going to gather evidence, and then we're going to analyze that evidence to see, does that evidence support or refute the original statement? That is how a hypothesis test is going to work. Now again, we have some terminology that we need to discuss before we can get into testing. So we have some more definitions. The null hypothesis, which is going to be denoted by a capital H with a subscripted 0, and we're going to read that as H naught. The null hypothesis is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed to be true until evidence indicates otherwise. So for us, that's going to be a statement that a parameter equals a particular value. So again, P equals 3 out of 4, mu equals 12 ounces, or something similar to that. So we're assuming that that's true until our evidence indicates otherwise. The alternative hypothesis, which is going to be denoted by a capital H with a subscripted 1, and we're going to read that as H1. The alternative hypothesis is a statement that we are trying to find evidence to support. Now, to be totally honest, I'm not a big fan of this specific definition because this definition sounds a little biased. This definition sounds like we don't believe the null hypothesis is true, and so we're trying to gather evidence to refute it. And really, that's a little bit biased. So we don't want to be biased. Basically, the alternative hypothesis is a statement that would be true if the null hypothesis is found to not be true. So it's not really so much that we're trying to find evidence to support the alternative hypothesis. It's just what's true if the null hypothesis ends up not being true. Now, typically, it is the case that there's a reason why we think the null hypothesis is not true, and that's why we test it. And if we don't think that the null hypothesis is true, then what would be true? Well, that's the alternative hypothesis. So when we're testing a single parameter, meaning like P or mu, there's three structures of the null and alternative hypotheses. The null hypothesis is generally going to be a statement that a parameter is equal to some value. And when I say some value here, I put that in quotes. It is a specific value, like 3 out of 4, or like 12 ounces. So there is a specific value that the parameter is equal to. And then the alternative hypothesis is going to be one of three things. It will not be all three. It will be one of the three. It will either be that the parameter is less than this value, or it will be that the parameter is greater than this value, or it will be that the parameter is not equal to this value. Now again, where I say some value here, that's going to be the same value. And again, for the alternative hypothesis, you will have one of these three things. You won't have all three, you'll have one of the three. Which one depends on what the researcher believes is true if the null hypothesis is not true. So for example, I gave the case of 3 out of 4 dentists recommend a particular kind of toothbrush. Well, if the researcher believes that it's in fact fewer than 3 out of 4, then the alternative hypothesis would be less than 3 out of 4. Or if the researcher believes that it's more than 3 out of 4 that recommend this toothbrush, then it would be greater than. And if the researcher doesn't really know if it's greater than or less than, they're just checking to see is it 3/4 or not, then the alternative hypothesis here would be not equals to. So it's going to be whichever one the researcher believes to be true. Now what the alternative hypothesis is matters because that affects the type of test that we're going to do. If the alternative hypothesis is a less than, the parameter's less than some value, that is going to lead to what is called a left-tailed test. But if the alternative hypothesis is that the parameter is greater than the value, then that's going to lead to a right-tailed test. And if the alternative hypothesis is that the parameter is not equal to the value, then that's going to lead to a two-tailed test. So again, we have one of three structures. We're going to have the null hypothesis versus this alternative hypothesis, or the null hypothesis versus this alternative hypothesis, or the null hypothesis versus this alternative hypothesis. So it's going to be those pairings that we're going to be using. And again, it's a big deal because if it's less than, then that's a left-tailed test. If it's greater than, it's a right-tailed test. If it's not equal to, that leads to a two-tailed test. And so that's the significance of this. Now, what do we mean by a left-tailed, a right-tailed, or a two-tailed test? Well, we'll get into that in a lot more detail in future videos, but basically here's the idea. If we have either like a normal distribution or a t-distribution that we're using that models the test, then if we're dealing with a left-tailed test, then that means we're going to be interested in what's going on in the left tail of that model. If we have a right-tailed test, then we're going to be interested in what's going on in the right tail of that test. If we have a two-tailed test, then we're going to be interested in what's going on in both tails of the test. So basically the idea is this shaded area would be unusual. This is unusual. So if our evidence ends up in this unusual area, then that would be evidence to refute the null hypothesis. Likewise, this would be the unusual area for a right-tailed test. And so if our evidence ends up in this unusual category, that would be evidence to refute the null hypothesis. And likewise, if it's a two-tailed test, then the area in the two tails represent the unusual area. So if our evidence ends up in this unusual area, that would be evidence to refute the null hypothesis. So we're going to stop this video here, and we're going to pick up in the next video where we're going to talk about errors.